Hi there, hope you have a fantastic day today. This lesson I will teach you application of differential equations. Of course, there is the PDF versions on the description below for you to download so you can work with me. Otherwise, let's go straight into it. First one, a certain bacteria population grows at a rate proportional to its current size. So this means that the rate, that is, let current size, the number of bacteria, if you like, so let is P. Okay, we talk about population. This is UP, more appropriate. That's all. So that means the rate of P, that means dP dt. Okay, the rate is proportional to its current size. That means K times P. So keep that in mind. So now we just need to solve for P. So to solve for P, we just need to separate P with dP. Okay, so I just times dt on both sides. So that means dP equal K P dt. And I divided by P on both sides. So that will give me dP over P is K dt. And we know that dP over P is the same as 1 over P dP is equal to K dt. Now I integrate both sides. So that will give me this. Okay, I integrate this, I integrate this. And if we integrate 1 over P, because we differentiate P, give me 1. So therefore, the answer is ln P. So ln P, that is K T. And don't forget, we add a C. So now we just solve for P. So we just unlock both sides. So this is the same as P is e to the kt times e to the power of c. And don't forget, e to the power of c is a constant. So let's e to the power of c is p naught. So that means p is equal to e to the kt times p naught. So p naught is exactly the same as this. Okay, p naught times e kt. So there you go. So now we need to find what is the initial population, if you wish, P naught and 5K. So the condition is initial population is 100 bacteria. So in another word, when T equals 0, P is 100. So let me just write this on here. Okay. So P is 100 when T is 0. So this means 100 is P naught E to the K times 0. So K times 0 is 0. So E power of 0 is 1. So therefore 100 is P naught. So this means that P is 100 E KT. Okay, we just substitute into this equation here. Okay, that's all it is. So now we need to find the value of K. So it doubles in 3 hours. So that means when T equals 3, from 100, we go to 200 because double 100. Because 100 is initial populations. Okay, so that means when T is 3, P is 200. So that means 200 is 100 E to the 3 times K is 3K. So there you go. So I divided by 100 on both sides. So that means 2 is E 3K. So to solve for K, we just take log on both sides. That is base E. So in another word, we take ln on both sides. So ln 2 is ln E 3K. So ln of E power of 3K is equal to 3K. So that is ln of 2 is 3K. So now I divided by 3 on both sides. So therefore, K is a third of ln2. So let me just put on a calculator and correct to 4 decimal place, because we normally use k with 4 decimal place. Okay, so keep that in mind. So I just go a third and we times ln2. So there you go, 0.2310. Okay, so therefore k is 0.2310. So now the actual equations is this, but we need to substitute the value in for k. So therefore P is 100 e to the k, that is 0.2310 t. So there you go. Part B. So we need to find the populations after 5 hours. So in another word, we need to find P when t is equal to 5. So when t equal 5, so P is 100 e to the 0.2310 times 5. That will give me, so just go 100 times e power of 0.231 we do times 5. So there you go, 317.40 and so on. But we're dealing with populations, so we just round up to whole number. So the answer is 317. 317. So therefore, so there you go. Part C. So we need to find the rate of population growth after 5 hours. So in another word, we need to differentiate this function here, and then we substitute t is equal to 5 hours. Okay, to find the rate at t equal 5. In another word, so let me just write down the function first. So P is 100 e 0.2310 t. And we differentiate this first. So dp dt is, so we differentiate this, that give me 0.2310, and we times 100. So that will give me 23.10, is same as 23.1 e to the 0.2310 t. And what happened is, we need to substitute t is equal to 5. So when t is 5, so this means that dp dt is 23.1 e to the 0.2310 times 5. That is, so 23.1 e power of 0.2310 times 5. So there you go, 73.319 and so on. Again, we dealing with populations, so whole number. Okay, so 73. So therefore, so there you go, 73 bacteria per hour. Now, if you think about it, we already found 5 hours, we have this many bacteria. And we know that the rate is this. Okay, let me just write here. So, or you can use these techniques. So we know that dp dt is kp. And we know that the populations when t equals 5 is this. Okay, 317. And we know k is 0.2310 0.2310. That is K. And we times P when T is equal 5. So that is 317. So times by 317. And we should get the same answer. 317, we times 0.231. That will do. So there you go, 73. 73 bacteria per hour. So there you go. So you can use either method. Okay, keep that in mind. Please pause the video and try this one yourself. Hi there, I'm back. How do you go? Let me just go through it with you. Before I do that, please do not forget to give me a thumb up and subscribe if you haven't done so you can help me to grow my channel. So let's get into it. So first of all, let me just let the amount of the substance present is Q. Or you can say M or whatever you like, okay? So it doesn't matter. I just use Q. Of course, you M also good as well, okay? Nothing wrong with that. So let me make the amount of substance is Q. And we know that the rate of decay is proportional to the amount of Q, if you like. So in another word, dQ dt, that is the rate, is proportional to, so that means K times Q. Now we just need to solve for Q. So we just times dt on both sides. So dQ is equal to K Q dt. I just need to separate Q with dQ first, okay? So now I divide by Q on both sides. So that is 1 over Q is dQ is K dt. Then I integrate both sides. I integrate this. So that means integrate 1 over Q is ln Q. So ln Q. That is equal to KT. We don't forget, we need to add a constant after the integrations. So now to solve for Q, I unlock both sides. So this means that Q is E to the KT at C. So this is exactly the same as Q is E KT times E to the power of C. And let E to the power of C is Q naught. Okay. So that means Q is Q naught E to KT. So now that is the equation, but we need to find the value of Q naught and K. Okay. So from the condition given, we know that when T is 0, because initially, and Q is 50 grams. So that means T is 0, Q is 50. Okay. So that means 50 is equal to Q naught E to the power of K times 0, because T equals 0. So K times 0 is 0. There you go. And E power of 0, it give me 1. So this means that Q naught is 50. So there you go. So this means that Q is, I just substitute into this equation. So that means 50 E to the K T. So there you go. Now to find the value of K, so we know that when Q is 20, T is 5. Okay, keep that in mind. So let me write it down. So T is 5, Q is 20. Okay, let's double check. Yep, 20 and 5. So now to solve for it, we just put that on here. So that is 20 is 50 E K times 5. So 5K. And I divide by 50 on both sides. So that cancel this first. So 2 over 5 is E to the power 5K. Then I take log base E on both sides. So that is ln. So ln 2/5 is ln E 5k. And do not forget, ln e to the 5k is exactly the same as 5k. Okay, they cancel each other out. So in another word, ln 2 over 5 is 5k. Then I divide by 5 on both sides. So this is exactly the same as this. 1/5 ln 2 over 5 is k. And let me just put on a calculator and round up to correct to 4 decimal place. Okay, so I just go 1 over 5 and times ln 2/5. So there you go. K is negative 0.1833. Correct to 4 decimal place. Yes. So K is negative 0.1833. So therefore the equation is Q is, we just substitute back to this equation here. Okay, these equations. So 50 kt, so that becomes 50 e to the negative 0.1833. So there you go. Part B. So we need to find the amount of substance remain after 10 years. So in another word, we need to find Q when T is equal to 10. So T is equal to 10. So Q is 50 e to negative 0.1833. We times 10. So that will give me, so I just go 50 e negative 1.833, okay, which is times 10. So there you go. And correct to 1 decimal place, so that is 8. So that is 8.0 grams. So keep that in mind. Now part C. So we need to find the rate after 10 years. So in another word, we need to find dq dt when t is 10. So what we can do is we can differentiate this and then we substitute t equal 10 in and give us the answer. But remember, we have 8 grams after 10 years, okay, when t equal 10. And we know that dq dt is equal to kq. Okay, remember that from the beginning. There you go. Or remember, we differentiate this and then we just substitute t equal 10 in and should give us the answer as well. Since we find out t is 10, q is 8. So we can just use this, okay, quicker, that's all. So that will give me k is negative 0.1833 and we times q. Q is 8 when t is 10. So that will give me 8 times negative 0.1833. So there you go, and correct to 2 decimal place. So negative 1.47. So therefore, so there you go. I hope you got all of them correct, and thank you so much for watching. Bye.